something, for example, let's do Hamming code. Okay, Hamming code looks at data, for example, 1011. If this was a data, this could be thousands of bits long. This could be a frame or a packet, but what we need to do is get a group of different bits into different groups. Say that one, this one, that one to group A, that one, this one, that one, group B, and so on. So we split it into three groups. And this is the basic idea. Imagine if we had some groups of the bits are in group A, for example. So it's, and maybe another group B and another group C. And let's write it down. So, for example, that one where is written there, that's the one, 0, 1, and 1. So now we have the bits split into three groups. Group A has the 1, this one here, and the 0 on the last one. So that's a group A, and so on. So it doesn't matter now the distribution, just watch out the basic idea. So we have a group B, that's the first, the third, and the last. So this is group B. So here they are in group B, 1, 1, and 1 are sitting there. Of course, we can also mark it. This is the D data bit number 1. So this is the data bit 1, data bit 2, data bit 3, and data bit 4. But don't worry about the order, or just get the general idea. We have the same string of bits and we split it into a number of groups. Some of the bits, they fall in 2 groups, and some of the bits, they fall in 3 groups. So now let's look at each individual group of bits. So group A has 1, 1, and a 0. Group B or C here has 0, 1, 1, and group B has 1, 1, and 1. And let's say we're going to go for Hamming code, can be either even or odd. Let's go for even. So we're going to be using Hamming code in even. What does even mean? It means all the bits in one group, they contain bits that have the value 1 in an even number, either 2 or 4 or 6 or 8. And if we were using the Hamming code odd, that means the number of bits that have the number 1. Like if we count the 1 values here, just the bits that are 1, there'll be an odd number. But let's see. Group A here has 1, 2 bits that have the value 1. That's already even. So we need to add an extra bit. We call it the parity bit. We'll always add a 0 or a 1. If we add a 0 here in this case, that makes the total number of bits that have the value 1 in A is 2, which is okay. Now we go to C. It also has 2 1s. So we'll add another 0 just to make sure that the number of 1s in C is also an even number. While here group B has 3 1s, so we need to add another 1 to make them 4, which is an even number. So that's what the sender does. And we send the whole lot. So we send all the bits, including the parity bits that were inserted by the sender. And imagine if the receiver received those bits, I'm just going to change one of the bits. Don't look now while I'm changing one of the bits. I just changed one of the bits that changed during transmission. So now the receiver receives these bits. Would the receiver know that one of the bits have flipped or changed? Let's find out. So what the receiver does, it receives again the frame with the parity bits. It will put them into their ordinary groups, group A, B, and C. And let's see, does it have, are the bits in each group, are they odd or even? They should be even. So let's go for A. A count. How many bits that have the value 1 in A? 2. That's even. That's good. So they don't need to be 2. They could be 2 or 4 or whatever, but any even number. That's good. There's no problem with A. So now let's look at group B, how many bits does it have? Oh, it has 3. 3 is not an even number, so there's a problem in group B. Now, let's look at the next group, group C, and it has 1 bit that has a value 1. That's an odd number, so there's a problem with group C. So now, this is the way we have it. Group A is okay. There's a problem with group B and with group C. So the problem is where B and C intersect, and B and C intersect in these 2 bits. So it has to be one of those 2 bits that have the problem. But also we have, see, this bit it's where group B and C intersect, but so does 1, but 1 has another little bit extra. It's group B and C and A intersect. So this bit 1 falls in the group A and also represents group B and also represents group C. But there's nothing wrong with group A, so we have to keep it out. So what we are really looking at, which of those bits is common between B and C, because B and C has errors, and actually not part of group A because group A is okay. So that eliminates that bit. That means only it leaves us with this bit, and that's how we make sure that this is the bit that has the error. So all we have to do is replace that 0 with 1, or if it was a 1, turn it into a 0, and hopefully that should solve the problem. Now we've solved the problem with B. How many bits that have the value 1 in B? 1, 2, 3, 4, that's even, so that's okay. In C, 1 and 2, that's also another even number, that's okay. And in A, it's 2, and that's already unchanged. But that's how in Hamming code we could, that's the main idea. It's not exactly how it works, but we can see once you get the main idea. So the main idea in Hamming code is we take all the bits, split them into groups, like the bits, each particular order, in a particular order of bits, they form group A, group B, group C. And then if one bit goes wrong, then we see which bit it belongs to and which bits it does not belong to. And that tends to make it very easy to find out which one it is. Now, let me give you another example. Imagine if this is, again, this is the data sent by the sender, but this bit went wrong, flipped along the way. So remember, now we have 1, 0, 1, 0, 1, 0, 1, 0. This bit changed, which is this one here. So now the receiver receives it. Let the receiver perform the check that it normally does. So it counts A. Do we have even number of ones in A? No, we have an odd number. So there's something wrong with group A. What about B? 1, 2, 3. Oh, that's another odd number instead of even. That's another problem with group B. What about group C? 1. That's another odd number. Then there's a group C. Now, all 3 groups have something wrong with them. So which bit is part of group A and also part of group B and also part of group C? Where do they intersect? The 3 groups, they have 1 bit in common. Which one it is? And it's this one here, and it's correct. And if we change that to 1, we'll be able to get everything fixed. And that's the basic idea. And now maybe if we change to the other camera. So now go back to the integrated one. So this is our way of doing this particular lecture. I hope you enjoyed it. And if you have any questions, please let me know. I'd be happy to respond to your answers. Thank you very much and goodbye.